Hi, again I'm Bob Pryor, and we're discussing formulas in section 1.7, and there's not the kind of formulas where the mad scientist mixes all those things together, and creates this explosion or whatever. No, it's not that kind of formula. Instead, it's algebraic. It's got letters, and we replace those letters with numbers, and we get some interesting values, I guess you could say. We're going to start, you have read this section, haven't you? 1.7? Well, if you haven't, be sure you read it after I'm done, because I'm not going to go over every single thing. So, let's start on page 2, in fact, page 1.7-2, with example 1. And what we've got is a very simple formula, d equals r times t. You'll later learn that this is distance equals rate times time. And we're given some values called replacement values. R is 50 and t is 2. And we simply put these values into the formula, so that our new, and what it is basically, we have two variables, actually three variables, d, r, and t, and we're going to replace two of them with actual numbers. And that means that we'll still have a third variable that'll equal a number that we'll just discover what it is. Anyway, r is 50 times t is 2, d equals 100. Now, we're not told what kind of units this is. This might be 50 miles per hour, and t might be for 2 hours, and so the distance traveled might be 100 miles, but it could be in kilometers or inches or feet, and the time could be in minutes or seconds, hours, months, days, who knows. Anyway, here we have this formula. It's all about evaluating the formulas. B, E equals 9r, let's mean 9 times r, over I. And in this case, we're told that the value of r is 10, and the value of I is 45. This is a formula actually used in baseball to calculate a pitcher's ERA. If you're not familiar with that, it's okay. It's just right now it's a formula. The value of r is 10, the value of I is 45, and it looks like this equals 90 over 45, which is 2. By the way, for a pitcher's ERA, that's a very good ERA, 2.00, most likely. Anyway, here's letter C. M equals x minus p all over y minus q. Now, this formula actually is, we're going to use this in our textbook in Chapter 8. It's a formula for the slope of a line. Now here we have 5 variables. M, we have x and p and y and q, and we're going to be told 4 of them, and it'll help us find the value of m. Let's see, what do we have here? X is -2, p is 4, y is 6, and q is -3. So we've got to put them in carefully into this formula. Let's see, m equals the value of x, that's -2, minus p, that's 4, all over y, that's 6, minus q is a -3. Notice I put parentheses around the -3, minus a -3. That becomes, in fact, I'm going to write it this way, -2 minus 4 over 6 plus +3, or 6 plus 3. Now I'll simplify this fraction. -2 minus 4. Oh, I could have made that plus a -4, huh? Excuse me. I got that a little sloppy. I'm sorry. -2 plus a -4 is a -6 up here over a 9. And a negative divided by positive is negative. And that fraction 6/9 reduces by a factor of 3 to 2/3. So it's -2/3 in all. Okay? Almost made a mess of that. I'm sorry. Let's see. How can I squeeze letter D in here? D is C equals the square root of A squared plus B squared. And we're told the values of A and B. A is 3 and B is 4. So carefully here, and again using the order of operations, the square root of A squared is 3 squared. In fact, I'll write parentheses around that. Plus B squared is 4 squared. The square root of, well, 3 squared is 9. 4 squared is 16. And now we'll add within to get C equals 5. Okay, good. And then there's some exercises for you to do, of course. And as you read, you'll next find some formulas from geometry. I've written 2 of them here on the page, and we're going to use those in example 2 on page 4. A says, find the perimeter of a rectangle where the length is 8 feet, it says, and the width, W, is 6 feet. Well, that's not too challenging. Perimeter equals 2L means 2 times L, plus 2W means 2 times W. So first of all, we have to write the formula down. Now we can put the values in. L, we're told, is 8, and I'll leave the feet off until the very end. Plus 2 times W, which is 6 feet. And because they're both feet, feet and feet, you know, we're okay. And the perimeter will be in feet also. Using the order of operations, we get here 16 plus 12. Did I do that right? I hope I did. I can check over here. Yay. Oh, and gosh, I'm sorry. I missed in the book. It did say 8 feet and 6 feet. So this is now 16 feet plus 12 feet. A total of 28 feet. I should be more consistent with that, huh? Yeah. All right. Well, there you go. When in part B, we're going to actually multiply the area of a triangle, and A is 1/2 B times H. You know, there's that formula right there. We're told, though, in this case, is that B is 10 inches and H is 7 inches. So when I put all of this together, we get something kind of interesting here. A equals 1/2 times B is 10 inches times, I'm going to use this times sign here, H is 7 inches. And when we look at the numbers, we've got 1/2 times 10. Half of 10 should be simple. Yeah, that's 5. Inches times 7 inches. So we're going to get 5 here times 7. But you know what we also get? This is interesting. We also get inches times inches. Inches times inches. Something times itself. Yeah, that's right. Yeah, in fact, inches squared. Yeah. Area is in square inches, or square feet, or square meters, square miles. This is why we're multiplying inches times inches, inches squared. This is not 5.7, that's 5 times 7. Emphasize that. So the area is 35 inches squared, or we might say 35 square inches, or we might say 35 SQ for square, IN for inches. Okay? But this is good right here. There you go. 35 inches squared. All right. I didn't include, I'm going to erase all this, go on to example 3, and I didn't include a formula, but I will in just a moment. Here's example 3 on page 5. And we're given the, what is it here? We're asked to find the circumference of a circle. Circumference is like perimeter. It's the length around the object, circumference of a circle. C for circumference equals 2 times pi times r, where r stands for the radius. And pi is an approximate value decimally 3.14. It's actually a value that goes on and on and on forever. And you've probably seen that earlier in Chapter 1 when we introduced irrational numbers. Well, pi is one of those irrational numbers. But we use an approximation 3.14. So I'm going to, for example 3, A is just the area of a rectangle. So we're told that the length is 9 yards and the width is 5 yards. But the area of a rectangle is length times width, and that means the area is 9 yards times 5 yards. And again, well, 9 times 5 is 45, but yards times yards, that means yards squared, something times itself. And we'll abbreviate it that way. Okay? Yards squared, 45 yards squared. Now, as far as part B, we'll use this circumference. We're told that the, I'm sorry, a little bit side for a moment. 2 times the radius, 2 times the radius, that's what it says right here, 2 times the radius, that's a diameter. So I wasn't paying careful enough attention. Look what happens when you don't pay attention. Get messed up. Diameter times pi. This is the same formula. Diameter times pi. And the reason I mentioned that is because I noticed that the value that we're given was that the diameter was 5 meters. And I wasn't given the radius. And I thought, oh, goodness, how am I going to work around that? Well, just alter the formula. There's a number of ways we can write the formula. We're told also that that the pi is, we're going to use 3.14. So the circumference here is diameter times pi, using it there. The circumference is 5 meters times 3.14. That's what we're going to use for pi. Now, when we do it that way, with an approximate value, see the 3.14, I really need to change that equal sign into an approximate equal sign, kind of like this squiggled equal sign that I have right here. So let me erase this equal sign and put in the squiggle equal sign, means approximately equal to. And for this particular problem, we're going to have to multiply off to the side. 3.14 times 5. See, 5 times 4 is 20, so 0 carry the 2. 1 times 5 is 5, plus 2 is 7, no carry. 3 times 5 is 15. And we see over here 2 decimal places, so I need 2 decimal places here as well. And it looks like I'll put the decimal point right here, 15.70, or just 15.7. So, to complete this, C is approximately 15.7 meters. That's what the M stands for. Let me put a box around that too. I'll put one over here. Okay, there you go. All right, let's go on to our next slide here. This is in statistics, the average. In fact, you can use this in yours to calculate your test average or your quiz average. And it's only, you can only test the average when, like this anyway, there's a different formula if they're different points on a test. But if the tests are all 100-point tests or 50-point tests or 10-point quizzes, then you can use this average formula to figure out your average. If it's not, there's other things to it. That's not a little bit higher math, not too much, but anyway. I'm going to look at example 4. I'm not going to do any of the reading here. You're going to do the reading, right? So I'm not going to explain that part. But I'm on page 6, and we're looking at example 4. And we're told that Carla received test scores of 77, 85, and 90. And the question is, what's her average? And then write it as a complete sentence, which I won't do right now, but you need to. Yeah. A equals, that's for average, Sum of all the data values. See that up here, that numerator? Whoops. Sum of all the data values. That means we have to add these together. So I'm going to write it, first of all, 77 plus 85 plus 90. Divided by or over the number of data values in the set. Well, how many do you see? 1, 2, 3. We have 3. 3 tests, or probably what it is. And then what we have to do is add those numbers up. You do it. I'm just going to look here. It's 252 is what these add to, over 3. And then we just use long division, 3 into 252, to figure out what that is. 3 into 25 goes 8 times. 8 times 3 is 24. Subtract, we get bring the 1, bring down the 2. 3 into 12 is 4 evenly. So this is equal to 84. And that's example 4. Example 5 would be done very similarly, and I'll let you read that. Okay, that's using the average.